Hi, welcome to Beginning Atari ST STOS Basic number 2, The Screen. Make a thing. Let's make a thing. Let's make a thing. Yeah. Today we're going to cover how STOS uses the screen for graphics that are not STOS sprites. We will cover a few drawing operations also, and how to make an animated graphic from a graphic of tiles rather than a memory bank of sprites. Okay, let's get started. Alright, so we're in VS Code here, and first of all I want to highlight this and talk a little bit about it. Here's a note on comments in code using VS Code. Rem statements are included in your basic program when you use them. Technically, these are called remarks, but are shortened to rem. The C-style comments that beginning with 2 forward slashes per line or a block surrounded by the slash star and the star slash are not included in your basic program. So I'm using a lot of double slashes to highlight what we're going to do, but when we actually compile those, they will not take up space in your programs. Rem statements will though. Okay, so what are we going to do first today? The most important command dealing with the screen in any new language I have found is clearing the screen. This is the CLS command in STOS. The second most important command is the graphics mode. We set the graphics mode with the mode command. The ST has 3 modes. Mode 0 is low resolution, 320 by 200 with 16 colors. Mode 1 is 640 by 200 with 4 colors, and mode 2 is 2 color 640 by 400. That's really a black and white mode. So how does STOS use screens? STOS has 3 built-in screens, plus you can create more. The physic screen, called physic, is the location in memory of the viewable screen, what you actually see. If you draw to this, it will be shown right away. The back screen is the address of the background screen. This is an exact copy of the physic screen minus the sprite. So if you draw sprites on the physic, the background is actually the screen used to replace parts of the physical screen that the sprites go over. So the sprites actually look like they're hardware sprites, but they're not. Logic. It's usually set to the same address as the physical screen, but it can be changed. If the address is the same as physic, by default, things you draw in logic will be shown right away. If you change it to a different memory address, then you can double buffer your drawing. We'll get to that soon. Logic can also be assigned to the background screen for any memory bank that contains a screen. Also, you can reserve a memory bank as a screen, and you can draw there and hold images. We're going to be doing that in the final lesson today. Okay, we've added a couple things to our code here. We're going to add something called key off, which turns off the text cursor. And then we're going to be getting the palette from an image. Unlike a sprite bank, pulling the colors from an image is very simple. You just use the get palette screen command or get palette physic as an example. Okay, so it's to our code. We're going to load a graphic in. You need to copy pic.pi1, which is a Degas uncompressed file, from the STOS folder to the root of the STOS project folder. I've already done that if you've downloaded this project. Set the function keys here like we won't discuss that anymore. Here's our tiny little program for this time. First, we clear the screen with CLS. Then we have mode 0, which puts us in the low resolution mode. We turn off the keyboards, we turn off the flash of color 2. We load pic1.pi1 to the background, and then we get the palette of back, and that'll show it in proper colors. Okay, let's take a look at that right now running in STOS. All right, we're in STOS now, and let's load in our first screen. Let's load in screen number 1. Let's find it. Code first. So screen1.bas. As you see, I've already saved off our 5 lessons for today, and we're going to load them in after we discuss them, and we're going to play each one. So, okay, here's the first one. Okay, so the first one loads in this STOS screen, and it shows it. That's basically it. And we've got the palette from the screen. So if we didn't, these colors would look very weird. Let's do default. Let's list out our program code. A couple things I want to show you here. One of them is that all of these blank spaces are where we had our C style comments. So they're gone now. And here's our rems. Now, we don't actually have to get the palette from this one. I'm pretty sure that this image, this pic.py1, uses the standard STOS palette. So it doesn't matter because this is the loading screen for STOS. So it pretty much sets that palette as STOS loads. But if you had loaded in anything else and changed the palette, you want to make sure you get the palette for whatever the current screen is so you can use it. Okay, on to lesson number 2 called Screen 2. All right. Now we're on screen2.stos. This is what we're going to learn in this one. We're going to reserve a screen, and this will set a memory bank aside and allocate it to hold an entire screen. Then we're going to use something called appear, and this is a command, one of the sort of special effects commands in STOS. We're just doing a demo of these. We won't use these very much. They're really good for menu and loading screens and things that maybe demo coders might use in some way, but you get a bunch of free ones in STOS. Unfortunately, there are 79 of them, and they don't tell you what they do, so you got to play with them. We're just going to play with one here. What the numbers do when you do appear is kind of up for trial and error. I found one that I kind of like, and so we're going to use it. First off, in our STOS program, we're going to turn the cursor off. We're going to mode 0, key off, flash off, that we have been doing. We're going to reserve a screen as 11. We're going to load our pic.py1 into 11. And then we're going to get the palette from 11. And when we do appear 11,2, the appear will take the picture that's in screen 11 and it's going to make it appear on the physical screen. You don't have to put physical here at all. It just knows when you do these commands that they will appear on the physical screen. Okay, let's run this little test and we'll show you some interesting little things you can do. You're not going to use this very much, but when we make a title screen, we'll probably use one of these. Okay. Let's go over to STOS right now. I will say that I'm not copying this code over to main.stos and building, but this is what we'll need to do. I've already built these. Just to reiterate what you would do if you're doing this yourself is you would copy the code from screen2.stos over to main.stos. Let's do this right now just to show. Control A, Control V, and then main.stos, you would hit Shift Control B and you would build it. And then you would go load in STOS, load in the main.stos as an ASCII file and run it like we did in the first session. We're not going to go through that again. We're speeding up and not showing the basics of how to use the environment. We are going to be showing just the results, and I've saved all the results off as .bas files in STOS, so they're easy to run. You saw the first one. Let's go to the second one now. All right, we're back at STOS, so let's load in screen number 2. We're loading a .bas files that we've created from our ASCII files. All right, let's run screen number 2. All right, so what this does is it does the fade in. It does the fade in of that same STOS screen. But look, my mouse covers up the screen. And the reason that is we didn't load we didn't load this into the background too. So let's take a look at the code. Now let's do a default. So because we loaded it, we appeared, we would need to do something like this. On 2020, we would have to say back equals 11. And if we do that, we run this will work, then our mouse will not remove the screen because we have both the physic and the back have the same graphic on it now. And so the mouse, which is actually sprite number 0, you can set this to anything you want. So because it's sprite number 0, it's actually the 16th sprite. So there are 16 sprites, but the mouse is one of them. So really you use 1 to 15 for your other sprites. You can set this to any graphic you want also. So the mouse acts as a sprite, and now that we have a background there, actually moves across and doesn't erase it. Okay. Let's go back and look at lesson number 3. All right, we are in screen 3.stos, and the goal of this one is pretty simple. We're going to create an object using graphics. We're going to make a triangle, and we're going to learn how to move that across the screen using what's called a screen swap between the physical and logical screens. And we're going to use wait VBL to wait for the vertical blank. So we're going to learn a lot of interesting things in this one. So we're going to have some code back equals logic. This lets you set logic to be the address of the background screen. And when you do this, it gives us the ability to do a simple screen swap between logic and physics to stop a jittery animation. And we don't need the background screen right now because we're not using any sprites. So we can use logic equals back in this one. We could set logic to equal screen 10 or something like that, and then we could also screen swap there. We'll maybe do that in a further lesson, but not right now. Okay, so since the back is not visible, anything we draw to logic is going to be invisible to the user. So that's why we're setting logic to back. If we didn't do that, then whatever we drew to logic would show up right away, because logic and physics show the same things unless we set logic to something else. With auto back equals false set, all of our drawing will go to logic and we can double buffer. Now auto back is cool because auto back false speeds up our animation. When you're drawing things in STOS, it tries to draw to the physics in the back to use back as a way to, when sprites go over the background, it will use that to redraw to physics. You don't need that when you have auto back equals false because we're not using sprites at the moment. Okay, so we're going to use the polygon command. You probably won't need this very much. There's lots of drawing commands in the STOS manual. I'm using something that starts on page 140, but we're going to go beyond what they're doing. Let's see, we have something called ink. Ink, INK is going to set the current drawing color for our triangle. So let's take a look at our code. So this is going to be a little more complicated. We're going to do a few more things that we've done before. We're going to turn our cursor off like we've been doing. We're going to use mode 0, key off, flash off. That just sets up our screen. Okay, so now we're setting up 3 points. X1 and Y1 are 50, 50, then 75, 100, and then 25, 100. That's weird. This will draw us a triangle. We're going to clear the screen. We're going to, like we said, we're going to set logic to equal back. We're going to turn auto back off, so we only are going to draw to logic when we draw. And then we are going to create a for loop. We're going to go from 0 to 244, step 1. And then the first thing we're going to do here, we're going to set ink 0, which is the background. We're going to draw our triangle every loop with the background color. So that's going to erase where it was before. But we're going to draw back to where it was. Then we're going to use ink 1. We're going to draw to the current location of the triangle. Then we're going to do a screen swap, wait the vertical blank, and then we are going to, next to I, we're going to run this again. And what this will do is move the triangle across the screen. There's some interesting things here. Our problem here is that when we do a screen swap, it's going to be swapping every other frame. It's going to be showing logic or physics. And because of that, when you get to one of these, it's always going to be 2 frames back when you need to erase. But basically, this will allow us to show a triangle moving 1 pixel at a time smoothly across the screen. Okay, let's go over to the code and let's show this running. All right, we're back in STOS after going through the code for lesson number 3. And let's load in number 3. All right, here's our triangle moving across the screen, and it's flicking between logic and physics. And what I was trying to explain is because this is not, we're not using the vertical blank. Oh, actually, we're using the vertical blank, but we're not drawing to logic on every operation. We're drawing to logic on one and physics on the other and flipping between them, which isn't a regular way of doing screen flipping. We'll get to real screen flipping later on. That's why every time we erase the triangle, we have to look back 2 pixels because it's on a different screen. It's on logic on one, then physics on the other. We're not going to use this really for any reason. We may do something with graphics, like we're going to try to make an original Asteroids game or something. We may use vector graphics like this. It would be very slow in STOS though. I think it'd be better to do in C or GFA Basic or something, but we can try it. One of our goals later on will be to try and make an entire game just drawing the graphics, possibly caching them in a way, and I'll explain the caching later on. Okay, there is the triangle going across the screen for screen 3, and now let's go on and talk about the code for screen 4. Alright, now we're on screen 4.stos. We're going to take a little bit of a break from showing animation, and we just want to explain a little bit of how STOS uses colors. And we're going to show a demo that I found in ST format, I think it is. I listed in here, and I kind of used part of their demo. I used some part of mine to do this. The palette colors. Let's take a little further look at the palette and a few graphics tricks. We're going to use the color and graphic demo from ST format September 1992 as a jumping off point in this exercise. So if you want to take a look at that when you can, it kind of explains a little bit more about this. Ending our programs a little differently now, so I'll show you. At the end, we're going to do a wait key and a default end, so that now at the end of something, you press the space bar and then it will default and end our program, so we'll revert it back. You'll see what I mean. Okay, so we're going to get a little groovy with some colors and the shift command. The colors are set on register 0 to 15. We've talked about this before. 0 normally represents the background or a transparent color. It isn't actually transparent. It's more like index color 0 from a GIF or GIF file. When we talked about sprites in the first video of this series, we said that you can manually set the palette, and in that video we pulled it from the sprite bank with some special code. Well, here we're actually going to set the palette, and we're going to set it to a specific colors that we want. And so when you set it, this is color 0, and the second one is color 1, all the way up to 15, 0 to 15. Very simple. These are hex values. So this is 0 is actually 0. FFF, probably actually FFF is, in this it would be 777. The highest you can go in this is 777. So instead of FFF, where we'd be 777. So we could easily pull the palette from an image, as we've seen in the previous example with the get palette screen command, but we're not doing that here. The colors are set using 0 to 7 values for each red, green, and blue. $000 is black, because we have 0 of each color, and 777 is white because you have the max of each color, which actually shows as white. 700 is red because it's max red, and then zeros for green and blue. INC versus INK. In this example, they use INC to increase a value of a variable by 1, and they use INK to set a color. These are two STOS commands. INC and INK do vastly different things, but even in their code, whoever transposed their code into the magazine did it wrong. So they put INC where they should put INK, and we'll explain that when we get to them. And then we're going to use a for loop, which you've seen before, that iterates over a set of numbers. And then we're going to use an if statement, which is used to test a true or false condition. There's a lot more about that in the STOS Basic manual. Okay. So let's start looking at this. We have our starter STOS program. We have the key off. We have curse off. We're hiding the mouse. We set our palette colors. And then we're going to create 4 small loops. And these 4 small loops, we're not going to go in detail of what they do, but they're just going to each draw lines coming out from the middle. And in each one, it loops between the various colors in the palette to show them. So see what they do. You know, this is a little artistic, but each of these 4 loops does something, and we're not worried about what it does. We're just kind of showing how to set the colors and things like that. When it's done, we use fade number 4, and then that's going to fade out what we've drawn to black. It's going to wait 50, which is, I think, 1 second, and then it's going to fade in new colors, and then we're going to press the wait key, default, and end. So basically, this one is just showing a graphics demo, demonstrating how to do the palette, and a little bit more on for and next loops, and a little bit on the if statements. If C is greater than 15, then C equals 1. This is looping through the colors each time. It's pretty simple, but you know, this is not something we're going to need to make our game. This is just part of a graphics demo. I just wanted to show it. So let's take a look at that right now running in STOS. All right, we're back to show that graphics demo for screen 4. It's kind of interesting. It's not something you'd use that often, but we're gonna make intro screens and title screens and stuff in this and use some of the STOS facilities when we get there. And we may do something like this. Probably not something exactly like this though, but it's an interesting one to look at. Let's run. This is kind of cool. So you get your rainbow. It's looking kind of cool. And then it fades out and it fades back in. That's it. That's it. There wasn't a lot of code there, but you have 4 different loops that hit that, and then you just change the palette. So this is kind of showing you how easy it is just to swap the palette on something. And later on, in some cases, we're going to get to doing this on an STE, and you could do it on the ST too, but it's easier on the STE. There's a way to swap the palette on different scan lines so you can actually have more than 16 colors on the screen, something that we will get to at some point. Timing is interesting on something like that. So, okay, so that's screen 4. Okay, let's go talk about the code for the next one, which is really the meat of this, which is screen 5, which is how we use the tile sheet. I'm going to go into Neochrome in a little bit and kind of show this tile sheet that I pulled off of Ari Feldman's Spritelib. So let's take a look at that right now. Now we're on screen 5.stos. This one, we're going to make use of a couple special commands. The screen copy command, and the screen as a string command, and we'll get to those. I've detailed up here what they do. If you look at the code, you also look in the manuals. It's very simple, but the screen copy command copies an entire screen from one to the other, or you can copy part of the screen to another screen. You just have to know that you can start your X values when you're copying from anywhere, but when you're copying to, you can only copy to values that are divisible by 16. Well, 0, 16, 32. And the reason for that is that's the way that the ST shows the screen. It stores graphics data in long strips down the screen of 16. One of the slow things that STOS does is to get around that with its sprites. We're going to try a faster way of doing that. We're going to get to a faster way in the next video. But here we're just showing how to use screen copy, and then you can store pieces of graphics into a string, and we're actually going to show it into an array of strings. So let's get to that. So our startup program, we have our key off, our curse off, our hide, and our mode 0. First thing, we're going to reserve as screen 10. This is our first time actually using one of these. We're going to load in something from the Spritelib GPL by Ari Feldman that I have access to, and anybody can have access to it. Ari's a great guy. I worked with him before in a couple books. Load chopper PI1 into 10. So we have that chopper.pi1 is actually now in our STOS folder. I copied and put it there. We're going to get the palette from 10, and now we're going to screen copy all of 10 to physics. So we're going to show the full sprite sheet on the screen. So I'm going to show that to you right now of what that full sprite sheet looks like. And the last 3 parts of that sheet are 3 helicopter images we want to show. We want to animate through them. So I went to Neochrome because I couldn't find how to do this in Degas. I loaded in the screen and I found the 3. So let's go to a little demo of how to do that in Neochrome right now. All right, here's Neochrome. Neochrome might be familiar to many ST users. Simple, we're going to show our sprite sheet. So let's get to it here. To load in a file, you right click, and we have a PI1 that we want to load in. So we right click, and we are going to find our the sprites. All right, and so it turns out that we want to use these 3 images at the top. So these 3 helicopter images, number 1, 2, and 3, a helicopter facing us, and only thing that really changes is this rotor blade is changing. So I looked at this and I saw that the way the sprite sheet is set up is these sprites are 32 across in this first row. They're all a little bit different, but they're all the same per row, which is pretty good. But these are 32 across and 20 down, and so is this one. But it doesn't start at 0, it starts at 1, and then it goes from 1 down to 20. Let's see. And in Neochrome, you can actually read right here on the screen, down, you see in the lower left, it's showing me the X and Y values of where we are. So this is how we find out what we want to pull from our sprite sheet. Sometimes a little trial and error, but we're going to pull each of these three, and then we may use these for our game too. I was thinking that, but I think that we're actually going to be using, we'll get to this next time, but we're going to be using this truck at the bottom, and you're going to be able to turn the truck back and forth and shoot. But your missiles, as you see, aren't going to go in a straight line. So, and you're going to be shooting at airplanes that are in the air, and or maybe we'll do something else. This might be more complicated of a game to do, because we'll need to have more things that use a lot more horizontal positions. I think we're going to do something a little simpler when we get to our game next time. So hold on to that. Hold that thought. Anyway, so this is our sprite sheet, and you'll see next when we load this up in STOS and run our program that we show this first, and then we show pulling all three of these off and then animating them, kind of like we did in the first video with the gorilla, but we're using no sprite, we're using only graphic images to do this. Okay. We're actually going to print something on the screen just so we can see it. We're showing this on the screen. We're going to show some inverse text that says press a key, and we're going to wait for a key press so we can move on to the next portion. So the first part is just going to show that sprite sheet on the screen. The next one is we're going to use screen copy to grab the frames from screen 10, and we're going to do something special with them. We're going to place them on the physical screen at 0, 0, which is the upper left-hand corner. This is going to happen so fast you're not going to see it. We're going to copy all three images, so 3 different frames of animation for the helicopter, each in turn. So we're going to screen copy. Here's our first one. We're going to screen copy from 10. We're going to start at 10. We're going to go to 205, 1 and 237, 20. That's 32 by 20 sprite, and we're going to copy it to 0, 0 on physic. Then here's the difficult part. We've dimensioned I as an array of strings. Those strings will hold the data for the screen. So we're going to pull from 0, 0, 32, 20. We're going to have an array that's going to hold the first 3 images of our sprite. And the reason we do this is you cannot directly pull into a string anywhere except values that are divisible by 16. But if you'll see, our screen sprites start at odd numbers, 205, 237 on X. You can't use the screen as a string with those type of values, but you can with screen copy. So we're going to screen copy them to physic, and we're going to pull them and put them into an array of strings using the screen as a string, using the physics. So here's our first frame, here's our second frame, here's our third one. We just saw those 3 frames in Neochrome. Okay, now we have another press key. The next thing we're going to do when you press a key is we're going to clear the screen, and we're going to loop through and animate that helicopter. So we're going to show the helicopter 100 times. We're going to loop through all 3 frames. So what this does is we have one loop, the counter loop, that's external. Embedded loops like this are very slow in STOS. We wouldn't do this normally. We're doing this just as a demo. We'll get to optimizing our code for games later. This is just to explain how we would do this. Inner loop, each time clear the physical screen, the location 0, 0 to 32, 20, and then we're going to show our first string of sprite on the screen. We're going to wait 5 frames, and then we're going to do it again. So you'll see what we're going to do. This is actually just a way for us to do an animation. And like I say down here, this is not code you'd use in a game. The code would be similar, but this is just to show you we don't need sprites, especially if we're going to put things at horizontal locations on the screen, which we're going to do on our first game. We don't need to use sprites. First of all, we're going to use a sprite in our first game. Anything that needs to move across the screen in anything but a multiple 16x location, we're going to use sprites. Anything that doesn't, we're going to use some of these predetermined graphics. It's going to speed up our game immensely. We can have a lot more graphics on the screen. Okay, so let's show this, and then we'll get ready for video number 3, which is coming up in a week or so. Okay, we're back for screen 5, and I know that so far it's been kind of complicated. This is one you're going to want to download the code, you're going to want to look at it, you're going to want to check it out, and you want to read through the STOS manual online. The entire manual is at AtariIndia.com. The entire manual is on archive.org. Download anything you can find if you're really thinking about doing STOS and go through it. I actually bought a manual off of eBay. We have 2 copies. I bought one for Fulton bought, and then I have one of my own from our original STOS. Good to have this manual. As you print out the manual and put it in a binder, you can do that too. It works good. This is something you want to print out if you can. Okay, so let's load in our final demo for today, which is screen 5. And we're going to explain what's going on. Okay, so we're going to run this. So here's our sprite sheet again, our tile sheet or sprite sheet, whatever you want to call it. It's a set of tiles or sprites that are organized per row so that you can easily pull them off. In the top row are 32 by 20, like we said. And the last 3 are the helicopter sprites. So when I press the space bar, it's going to do the operation where it pulls them off of screen 10. It's going to temporarily put them on physic, and then it's going to copy those from physics 0,0 to 32,20 to strings in an array, so then we can use them on the final one. So we press the spacebar now, you didn't even see it happen. And then it automatically goes to this one where we see the animation. So, and it runs interesting. I mean, it's very similar to when we showed the gorilla animating, but not moving yet. And we're going to get to movement in number 3 of our STOS. We're going to start building a game that uses some of the strengths of STOS. Oh, they went through all 100. We're going to start building a game that uses the strength of STOS we've shown so far. And we'll build a title screen after. In one of them, we're going to do some sounds and a little bit of music. We're going to do all of it. And so we're going to start in the next lesson. We're going to start creating our first simple game. Okay, until next time, into the vertical blank.
An 8-Bit Rocket Studios production.